In this lesson, we will learn how to multiply or divide rational expressions. If you're multiplying, you factor all the numerators and denominators first, then reduce the common factors. Do not multiply first before you factor. If you're given a division problem, remember your fraction rules of changing to multiplication of the reciprocal. Then factor all numerators and denominators first, then reduce common factors. Let's take a look at a real simple example of x plus y over 3 times 9 over x plus y. So we can see that x plus y as an expression on the top numerator and the bottom denominator, those two, if I put them on top of each other, would be equal to the whole number 1. And then if I take 9 divided by 3, I know that 3 goes in there to 9 3 times. So my final answer for this would just be 3. And again, if you're having a little bit of confusion with this, remember that multiplication can be done in any order. So let me do just a real quick writing. Here's x plus y times 9, 3 times x plus y. So let's say I did multiply them, just not distribute yet. I could always reverse that to be 9 times x plus y over 3 times x plus y. And that might be just a little bit easier visually for people to see. We still end up with the answer of 3. So we're going to take another sample, and I'm going to go ahead and walk you through this example. It has a little bit more factoring involved. It's still multiplication, so we don't need to flip the second fraction and make it its reciprocal. So let's go ahead and try this. So again, since I could write a plus 3 next to a squared minus 3a minus 10, I'm just going to do all of my factoring and make a list of factors in the numerator and denominator. So a plus 3 is prime, so I'm going to leave that one there, but I'm going to put it in parentheses, more from a visual standpoint. Now let's factor the a squared minus 3a minus 10. Two numbers we multiply to be 10, whose difference is 3, or negative 3. We want to make sure we have the right signs. So a minus 5 times a plus 2. Now let's work on the bottom two parts. Let's take the left denominator and let's factor that. A squared plus 7a plus 10. Again, I'm going to break that up into my two binomials. Two numbers you multiply to be 10 but add to be positive 7. So we're going to end up with a plus 5 times a plus 2. Now if we take a look at the a squared minus 9, that's a difference of squares. So let's go ahead and factor that one out. So a squared minus 9, that's a plus 3 times a minus 3. Now we start matching up our numerators and denominators. So here I have an a plus 3 in the numerator that matches with 1a plus 3 in the denominator. Here is an a plus 2 in the numerator and an a plus 2 in the denominator. Now it looks like the a minus 5 could go, but you'll notice it's a minus 5 in the numerator and a plus 5 in the denominator, so I cannot reduce those. And I cannot take just the 5s or just the a's, because again, that is like an addition problem. We can't factor from within addition. So basically we're going to write what's left. So I have a minus 5 on the top, and on the bottom I'm left with a plus 5 times a minus 3. And if required to multiply it out, this would be a minus 5 over a squared plus 5a minus 3a is plus 2a minus 15. Now let's have you try one. Pause the video, work through the problem, and then turn the video back on to see how you did. Now note, this is a division problem, so you need to remember the very first step in order for you to be able to factor and reduce. All right, let's go through this example. So since this was division, I am going to need to rewrite it as a multiplication problem. So I'm going to end up with a squared minus 2a plus 1 over a minus 1. And we're going to flip the second fraction, 2a plus 1 over a squared minus 1. Now we'll go ahead and factor all of the numerators and denominators that we can. In the upper left, we have a minus 1 times a minus 1. And over here we have a plus 1. In the lower left, we had a minus 1. In the lower right, we have difference of squares, which is a plus 1 times a minus 1. Now we'll start pairing up. So I'll take this a minus 1 and reduce it with this a minus 1. Now we have a whole number 1. Here's another a minus 1 over this a minus 1. Another pair done. Oh, and look, we have an a plus 1 over an a plus 1. So now that everything has been reduced to the whole number 1, that is my final answer. Congratulations!